Hello everyone, today we are going to continue our talk about factoring. Today we're going to specifically talk about a method of factoring for trinomials. And now just a quick reminder, trinomials we've talked about before, this is any polynomial with three terms. So that tri part of it is referring to the number of terms. Okay. What we're going to be talking about today is how do we go from something that has three terms and break it into the pieces that multiply to give us that trinomial. Now, using this factoring by trinomial method is going to be very closely related to foiling, okay, or multiplying two binomials together. So we're going to start with an example here, and we're going to kind of use that example to figure out what this method might be, and then we'll talk about how does that actually look when we get to those trinomials. So if I start with something like x plus 2 times x plus 3, if I FOIL this, I would start with the x times x, which gives me an x squared. Then I would add to that x times 3, which is 3x, then 2 times x, which is 2x, and 2 times 3, which is 6. Okay, now I would combine my middle terms here, so this is going to be x squared plus 5x plus 6. So foiling took me from two binomials, two-termed pieces, into one trinomial. What we're going to be trying to figure out today is how do I go from this trinomial back to the two binomials. So going forward, this is called foiling. Going backwards is our factoring. Okay, this is the piece that we're trying to get to today. So how do I go from an x squared plus 5x plus 6 and realize that that came from multiplying an x plus 2 and an x plus 3. Okay, so let's try and figure it out. To factor a trinomial, we are always going to start with something that looks like x squared plus bx plus c. Now it's important here that I did not put a number in front of x squared here. If we ever have a number in front of x squared and I give it to you in this section, it means that it's a GCF, and you need to factor out that GCF first and then do the trinomial that's left. Okay, you won't see a ton of those, but they may show up some. And then we're going to end with something that looks like two binomials. So it's going to be x with some number that comes after it, but it could be either a plus or a minus in the middle. And then same thing in the second one, x plus and minus some number. And I don't necessarily know what those numbers are quite yet. Okay, so let's go back to the pattern, or the number, or the example, sorry, that we started with. We had x plus 2 times x plus 3, and we took that and said that that's the same thing as x squared plus 5x plus 6. So my question now is, what patterns are there? So we're starting with an x squared, a 5x, and a 6, and I want to get that back to an x plus 2 and an x plus 3. So I'm going to start with this 2 and 3 here and see if I can do anything with the 2 and 3 to get the numbers that are here. Well, just looking at them, 2 times 3, that's my 6. So it definitely looks like I'm multiplying to get this last piece. Okay, we're multiplying is specifically 2 times 3. Okay, and the 5, if I'm following that same pattern using the 2 and 3, that's really them added together. So we're adding to get 2 times 3, or sorry, 2 plus 3. Okay, and if you go back to what we actually did with our foiling here, these make sense. This 6 that shows up in my answer here originally came from multiplying the 2 and the 3 together. The 5 is probably a little bit trickier because that came from combining my like terms, but when I combine those like terms, what I'm doing is I'm adding the 3 and the 2. So this idea of multiplying to get the last number and adding to get the middle number kind of fits the foiling that we have. So that's the pattern that we're always going to use. Okay, what I always remember this is we add to get b, and we multiply to get c. So add to b, multiply to c. Okay. Now there is a little bit of hiccups in there as far as what these signs show up as they'll start to change from pluses to minuses. That can cause some issues. So we're going to talk through these in kind of three groups. We're going to start with when all the terms are positive. Well, if all the terms are positive, then it makes sense that I start with positive terms as well. That's what I saw happen in this first example. So what I'm going to say here is that both are positive, and when I say both, I'm talking about these factors. These numbers that I have here are going to both be positive numbers, and so I see those pluses in my two binomials, my two smaller groups that are in those parentheses. So what I want to show you is a little table that I'm going to make for all of these. That's going to make this a little bit easier. So I know I need things that multiply to give me C and add to give me B. It's typically easier to start with multiplying because there's only so many things that multiply to give me 2. There's probably more things that add to give me 3. So let's start with, I'm going to write this as factors of 2. And I'm going to create a column here, and I'm going to say sum to 3. And if I can figure out what numbers work in here, I can figure out what my answer should be. So factors of 2. The only thing I can get that multiplies to give me 2 is 1 times 2. And if I take and add those, 1 plus 2 does give me 3. So this one actually works right off the bat. I know the numbers that I'm going to need are a 1 and a 2. So then it's just remembering what our pattern looks like. I know these are both positives because that's what I set up here. So it's going to be an x plus 1 and an x plus 2. And there is your answer. Okay, now, quick note here, you could switch these around. Okay, 2 times 1 is the same thing as well as 2 plus 1. So as long as these are both positive, you can switch these, say x plus 2 first and then x plus 1. Okay, going to example 2 here. Same idea, I need things that multiply here to give me 35 and add to give me 12. So let's try these. Factors 35 and sum of 12. Put my line down the middle there. Let's see if we can find these ones. I'm going to start with 1 times 35, because I know that works, but 1 plus 35 is 36. So it did not give me the sum that I need, so I need to try something else. Well, 35 ends at a 5, so I know 5 will work. 5 times what gives me 35? Well, that's 7. And then 5 plus 7 is going to be 12. So that's the one that works. So I know I'm using a positive 5 and a positive 7. So I'm going to say that this is x plus 5 times x plus 7. And I get my answer. Okay, now part of this, in order for this to work, is to remember that your answers are always going to look like this. It's what we set up here. It's x either plus or minus a number and plus or minus a number. What we're figuring out with these charts are what are the numbers. Based on everything being positive, I knew that they had to be a plus and a plus. Okay, now that plus and plus could change though as well. So if I go to my next page here, let's talk about what happens if b is negative. Well, if b is negative, okay, which means c is still positive, that means I have things that are multiplying to give me a positive, but adding to give me a negative. Well, anything that's going to add to give me negative is going to have some negatives involved. But if I have negatives involved, the only way to keep it a positive when I multiply is for them both to be negative. So here, both are negative. Okay, which means my answers are going to look like x minus some number and x minus some number. Okay, so let's try and figure out those numbers. If I look at the first one here, I want factors of 1. That sum to give me the negative 2, and it is important that I take the negative there. So let's start with 1s. Well, the only thing I can multiply to give me 1 is 1 and 1. So if I multiply 1 times 1, if I add them together, 1 plus 1 gives me a positive 2. So that actually didn't work. But what I'm forgetting here is that I don't have positive 1s. I'm saying right now that these are going to turn into negatives. So I have to use negatives here. But if I do negative 1 times negative 1, I still get the positive 1 that I need. And then when I go to add them, negative 1 plus a negative 1 is the negative 2 that I want. So negative 1s are what I want. So this is going to be an x minus 1 and an x minus 1. Okay, and it is possible to have two that do match like that. Okay, that is a possibility. So there's my answer. Let's try another one. Number 4 here. I want factors of 10 that sum to a negative 7. So I definitely have that negative b with a positive c. So I need things that multiply to give me a positive 10 but add to give me a negative 7. So I know I'm going to have negatives. I could try 1 and 10, but I don't think that's going to give me a 7. So let's just go to 2 and 5. And I only want to make both those negatives to give me the positive 10. And when I add them, negative 2 plus a negative 5 is a negative 7. So that one works. So what I would like to see you do is still make these tables for everything, but as you go through them, you're going to start to figure out that some things just aren't going to work. So like for that one, you saw me or heard me say that 1 and 10 isn't going to work because that's not going to give me a 7. And I can see that before I even start. So there's no reason to really write it down. What I want you to do, though, is use these tables, especially if we end up with one that we call prime where it doesn't work. It's really important to use this to make sure that you've kind of eliminated all the possibilities. Okay? So let's go ahead and try another one here. Or sorry, I got to finish this one. I got to write it as x minus 2 and an x minus 5. All right. So let's go ahead and take a look here at our last group, which is basically when c is negative. So this value down here at the end is now a negative value. And the only way I can multiply to get a negative is to have one number be positive and one negative. Okay, which means my answer is going to look like x plus a number and x minus the other number. So we get 1 plus and 1 minus. Now, those can't switch places if we need them to. Excuse me. But we just need to make sure they end up on the correct piece. So let's try this for number 5. I want factors of negative 21 that sum to give me 4. So I'm just looking 21. 1 and 21 probably isn't going to work. Those are too far apart to give me a 4. But maybe a 3 and a 7. I don't really know which one I need to make negative, so I'm going to start with the negative on the 7 and see if that works. So that definitely gives me the negative 21. And if I do 3 plus a negative 7, it gives me a negative 4. Now I want a positive 4. Now when I see that I get the right number but the wrong sign, I actually get a little excited because that means I'm close. Okay, I don't want to abandon what I have, but I need to change it slightly. What I can do to change it slightly is move my negative to the other term. Okay, so I'm going to move my negative from the 7 to the 3. When I now add these together, negative 3 plus 7, I've switched where that negative goes and I get the positive answer that I need. Okay, so that's important that if you get the right number but the wrong sign, just switch where your negative is. Do not completely change the numbers. It's going to completely throw you off if you try to do that. So just switch your negative if you need to. So my numbers here are negative 3 and 7. That means I have an x minus 3 and an x plus 7. Now, just a quick note again, you can switch the order of these, but you have to keep the negatives and positive where they go. So I could put the x plus 7 first and then the x minus 3, but I could not have this as an x minus 7. That's going to give me something different than what I started with here in 5. Okay, and as always, we kind of talked about this last time. If you want to check these, multiply it back out and see if you get to where you start. Okay, if you don't, then you have an issue. Number 6 here, I have x squared minus 3x minus 28. If we go ahead and try that one, we're looking for factors of negative 28 that sum to give us a negative 3. Negative 28, 1 and 28 is probably not going to work. 4 and 14 is probably also 2 and 14 are also probably too far apart. So I'm going to go to 4 and 7. I'll do negative 4 and positive 7. Plus 7 gives me 3, which again is the right number, but I'm off, so I just need to switch my negative to the 7. Which is going to give me 4 plus a negative 7, which is the negative 3 that I need. So my answer here is going to be an x plus 4 and an x minus 7. Okay, and there's my answer. Let me add in one more here. We'll call this number 7. Let's do x squared plus... let's go 5x minus 13. Okay, so if I just start out here, this does still fit the same group, so I want one positive, one negative. I'm looking for factors of 13 that sum to give me 5. Okay, well, for 13, my factors need to be a 1 and a 13. That's the only things I can multiply to give me 13. Now, I could try and make the 1 negative. If I do that, negative 1 plus 13 gives me a positive 12. Not the number I want, so I can go ahead and switch those. I can do 1 times a negative 13, but that gives me, if I add those together, a negative 12. Still not what I want. So, now you have a choice. You can either keep trying these, okay, but if I look, I'm pretty convinced that 13, the only thing I can multiply is 1 and 13, and I've tried everything that might work, and nothing is going to make that happen. So I'm going to pretty confidently say that this is prime, and that I cannot break it down any further than what I already have, okay? The thing I want you to be very careful of, if you say prime, you have to be convinced that you have tried every number. Okay, so there are some numbers that have lots of factors. There's some numbers that don't have hardly any factors. So for example, 13 only had 1 in 13. Okay, but a number like 12 has lots of factors. You could do 1 in 12, you could do 2 in 6, you could do 3 and 4. You need to make sure you check all of those pairs and all the combinations of where those negatives might go as well. So if you're going to say prime, I should see a big table here, or at least a table with some values, and you need to be convinced that you've tried everything. Okay, so be careful and confident if you're going to say prime. It doesn't show up very often, so it shouldn't be your entire page by any means. Okay, if you have questions with that or anything else dealing with factoring, let me know. But that is going to end this video, so reach out to me if you have questions, and we'll try and get you taken care of.